So these take a bit of doing, right? Okay. So notice that A is at a gravitational potential that's higher than B, which literally means that A is higher than B. Okay, so let's just draw a picture. Here's A, and it's at 563 joules per kilogram. And here's B is down here, right? It's at only 237. So, I mean, literally A is above B, right? Which means our gravitational field will be down and all this stuff, right? But I think, gravity tends to be a little more obvious, right? They're separated by 67 meters of distance. That's our delta R, right? So if I do this, I go up by 67 meters, right? Because I'm going to make this the positive direction, this the negative direction. Okay, what is the field strength? I think we can do that. Okay, remember G is opposite of change in Vg over change in R, right? Remember, any change is just final minus initial, okay? So if I go from here to here, my change is final minus initial. So let's do this. Opposite of 563, which would be my final, right? Minus my initial, because I started here and I went there, right? Okay. And then my displacement is positive 67. I ought to be able to do this. And these, by the way, are joules per kilogram. This is meters, joules per kilogram. Now, what you'll end up doing is if you divide a joule by a meter, you just get newtons, right? Because remember, a joule is a newton meter. So we'll end up with newtons per kilogram, which is exactly the units of electric field. So let's do this. Parentheses, whoops, clear. The opposite of parentheses, 563 minus 237 divided by 67. And I'm getting that it's negative 4.865, so 87, and that is newtons per kilogram. The fact that it's negative means it's that way, because positive is up on this page, right? So that means it's toward B, which you could have told me at the beginning of this, right? Because B is below A, right? It's always down, but that's okay. Let's see. Does it point toward A or B? Points toward B. What force in what direction does it exert on a 17? That's easy, right? G is F over M, so F is mg. That's 17 kilograms times negative 4.86567. This number unrounded, right? So 17 times that. That's 82, negative 82.7 newtons, right? So it's 82.7 newtons toward B. Because they don't know, IB doesn't know which direction we made negative, right? What would be the change in potential energy of the mass if we moved it from a point A 12 meters toward B? So not 67, we were just going to move it 12 meters. Right? Okay, we can do this. What I'm going to do is I'm going to do two steps here. I could just, by the way, use potential energy equals mgh, but that would be cheating. Let's use our field theory equations here. Okay. So the first thing I'm going to do is I'm going to find the change in gravitational potential. Okay. And I'm going to use this guy, right? That G is opposite of delta VE over R, right? So therefore the change in, whoops, that's a G. Change in gravitational potential is going to be the opposite of G times change in R, okay? So that's going to be the opposite of negative 4.86567, right? Okay, times, and then we're going to go down 12 meters, right? Too many minus signs. So this minus sign is the minus sign in the formula. This minus sign is the minus sign that indicates that that gravitational field is down when I made up positive. This minus sign is because the 12 meters is down. We're heading toward B, which is the negative direction. Okay, so we're going to end up with a negative change in gravitational potential, which of course we could have just known, right? You could have just done the math and go, well, we're going toward B, so it's more negative. But let's go with this. Okay, so I'm going to go times this guy. And I'm getting that is negative 58.388. And that's joules per kilogram, right? And then I'm going to find the change in potential energy, which, by the way, is the same as the work, right? Okay, so work is mass times change in gravitational potential. So it's, what mass is it? 17 kilogram mass, right? Times negative, our change in potential is this guy. Okay, so 17 times, that's negative 992.59, so negative 993 would be the change in potential energy of it, right? Now, you could also, by the way, since this is gravity and since we have a gravitational formula for the potential energy, right? You could literally, here we'll break out a little chunk of space here. You literally could just use the potential energy formula, couldn't you? Right, remember potential energy is mgh, right? So it would be 17 times negative, I'm going to go, okay, G we use positive in this case, right? So 4.86567, right, times negative 12, because we move it down 12. That should work, right? 17 times that guy, hold on, times, indeed, that also works, right? That equals negative 993 joules, okay? So, you could cheat a little, doesn't matter. Any valid way of doing it is perfect. All right.